Good morning and welcome to another episode of Science Radio. Today, we meet an eminent physicist and an expert on climates, Professor Goswami, Director of the Indian Institute of Tropical Meteorology in Pune. This is Science Radio on Vidyavani 107.4. Professor Goswami obtained his master's degree in physics from Guwahati University and PhD in plasma physics from Physical Research Laboratory, PRL, Ahmedabad. Subsequently, he pursued postdoctoral research at MIT, Cambridge. After his return to India, he spent a short time at IIT Delhi, following which he joined the Center for Atmospheric Sciences in IISc, Bangalore, where he became professor and chairman of the center. Professor Goswami has been the director of IITM in Pune since 2006. We caught up with Professor Goswami, the director of the Indian Institute of Tropical Meteorology in Pune, in his office. Sir, did your interest in science develop from your early school days, or was it a sudden shift before college?
From the school days, I was always interested in the universe. The astronomy and how the universe works actually fascinates young minds, and that was probably the beginning. Of course, the direction in which my ultimate research work took was quite different from the beginning. In MSc, my specialty was in nuclear physics. So I went to do research in Physical Research Laboratory. But I got fascinated with plasma physics, through which ultimately I became a physicist. When I finished my work on plasma physics, there was a group that was formed at the Physical Research Laboratory to do climate science. For a long time in our country, the weather and climate science has been mostly descriptive. Over the years, the climate science has become very, very quantitative. A lot of progress has taken place. However, in our country, that progress was not translated equally. With that goal, we started a small group. In 1977, there was an international conference in Delhi. We presented our results, and there was one very famous scientist from MIT, Professor Jules Chandy. So they were very impressed with our work, and we had some discussions. He invited me to come as a postdoc to MIT, and that was a turning point. And a couple of years in MIT changed the course of my final destination towards climate science.
What areas of physics find application to climate studies?
It's a lot actually. Physics is the basis. Biology and chemistry also is involved. However, driving of the climate is essentially the radiation balance. And the radiation balance is a thermodynamics problem, and it is basically a physics problem. It becomes more physics when it comes to actually calculating the radiation balance. Blackbody radiation, scattering and absorption of different radiation by the molecules and the particles in the atmosphere. In addition to these fluid mechanics and thermodynamics, other area where physics is important is, for example, the formation of the clouds also involves a lot of microphysical processes. But of course, the radiation balance eventually gets affected also by other processes like chemistry in the upper atmosphere. In the ocean, there are things like primary productivity. Some algae form due to photosynthesis from the sun, and these algae will absorb solar radiation, and the solar radiation can heat the upper ocean. Chemical processes as well as biological processes can influence the heat balance.
You did your postdoctoral degree from MIT. After your postdoctoral degree, you worked at NASA. Please tell us about some of your research at NASA.
At NASA, for the first time, we explained why within the monsoon season, we have some ups and downs. Sometimes monsoon is active, and then there is a question period where there is not much activity going on. This was known to meteorologists for some time, and it was found that there is an oscillation within the monsoon season with a periodicity of about 30 to 40 days. It was not known what selects that time scale. So for the first time we used a global general circulation model. We demonstrated that this oscillation arises due to interaction between how the clouds heat the atmosphere and how that heating produces response in the atmosphere. There is an internal feedback within the system which can regulate formation and the decay of the clouds. So we demonstrated that, analyzed the results of this output, and that theory is still today the basis for understanding these subseasonal oscillations in the monsoon.
After NASA, you worked at the Indian Institute of Science, Bangalore for a while. You've been the professor and even chairman at Center for Atmospheric Sciences. I'm sure you must have some memorable moments to share from your teaching days.
I have always loved teaching, and there are reasonably good students that come along. Atmosphere in Indian Institute of Science is good for doing research, and I have had the opportunity to work with some very good students. The challenge was with the limited resources that we have to be able to do world-class research. When I came back to India, actually our computer availability in the country was much behind. It's until only very recently that we have overcome that problem. To do competitive research, we had to decide problems which will not require that much computation, but still address science questions which are very cutting edge. It was always my dream to come back and work in India and still do equally good work. IISc gave the environment to do that kind of a work, and that was really nice and then very satisfying at the end of the day that we are able to do work which are as good as people do abroad.
In June 2006, you were appointed the director of IITM, Pune. How was the change from research to being an administrator?
It is a great learning experience. This was a sea change for me. I was not prepared for what I had faced. I was a complete academician and I used to just do my research and work with students. But here you come and then you have a lot of problems dealing with people, dealing with finance, dealing with the future of the institute. And I had no real experience in handling that many people. But I had some ideas. I was always associated with this institute even before coming here in various other capacities. I knew that this is one place where in the country there is a potential for doing good research, but unfortunately because of various legacy, that full potential is not being achieved. I did my own analysis and realized that there are 2 or 3 major issues. One of the major issues is, of course, the funding itself was very poor in the institute. As a result, the institution did not have a focus on science. Second major issue was this institute was formed out of IMD, India Meteorological Department. India Meteorological Department is largely a service organization, but they had a visionary idea that to improve the forecast, they formed a group dedicated to do research. But in IMD, a lot of scientists come from scientific support staff, but they did not have the right kind of training to become independent scientists. We needed to change that demography, to bring in more people so that they can lead new science. Recruitment was required, infrastructure needed to be improved. The third thing that was required was a certain amount of training is required. So I introduced immediately pre-PhD 2-semester training work. That has improved the quality of our research students. Now we have built a very strong group on modeling as well as a group who can do state-of-the-art field observation. From the time I joined, the impact factor publication has gone up 4 times. In 2007, we had a computer with 7 teraflop capacity. In 2010, we made it 70 teraflops. Today, we have 790 teraflop machine. It is number 36 in the world and best in the country.
This is Science Radio on Vidyavani 107.4. What are some of the highlights of your personal research which are important to you?
My major contribution has been understanding monsoon variability. I started to work on lows and depressions and then went over to work on these intra-seasonal oscillations. Then I did predictability of the monsoon seasonal mean, what is called long-range prediction of the monsoon. There is a lot of theoretical work which established that the seasonal prediction in the tropics as a whole is much better than the seasonal prediction in the extratropics. I did a lot of studies which showed that the reason behind this is there is an unpredictable component of climate noise, and that climate noise affects the predictable component of the monsoon, which comes from slowly varying forcing. So then we spent a lot of time trying to understand where does this noise come from. It turns out that this noise comes from the subseasonal oscillations that I mentioned about. What limits the predictability of the monsoon and how we can utilize that to improve the model predictions. There are a couple of other contributions that are very significant, which one of my students, we discovered a new mode of variability in the Indian Ocean, and that is called Indian Ocean Dipole Mode. So we published this paper in Nature, and this has become one of the most cited paper. In fact, in Web of Science, it is about 1200 cited. Until then, people were not looking at Indian Ocean very much. Now when this came up, there's a lot of interest in the Indian Ocean. So this opened up a new area of research. A lot of people have worked on it since then. So these are some of the interesting aspects.
Common complaint is that monsoon in India is very unpredictable. We'll never know when it's going to rain. Why is that?
There are two aspects that I think we need to address slightly separately. People always think that how the Americans are predicting, the Europeans are predicting 7, 8, 10 days in advance. Why can't we predict our weather? There is a fundamental difference. Weather in the tropics is less predictable. So that means the day-to-day fluctuations are much weaker. That means our signal is small. If the signal is small, your errors will grow to that level faster. So therefore our limit is predictability is low. Second thing is that the predictability is governed by how fast the error grows. The latent heat release in the cloud is the primary driver for our weather. And these cloud systems grow pretty fast. So if I miss one thundercloud, that error will then grow that faster. The climate is a result of nonlinear interaction between these weather phenomena. And therefore, that is again very difficult to predict. On the other hand, our climate comes from these slowly varying coupled ozone atmosphere oscillations like El Nino, which can be predicted. The location of the continent surrounded by warm waters to the south and the mountains to the north create an environment in which and the clouds and the circulation interact very vigorously, and that produces this internal noise to limit our predictability of the monsoon.
India as a country is primarily an agro-based economy. For farmers to generate better yields, accurate monsoon predictions go a long way. How well are Indian farmers equipped with this information, and what measures are being taken for the latest information to be sent to the farmers?
I think that's a very good question. In fact, that is true. The farmers can be benefited by both skillful weather forecast. Even if it is 3 to 4 days, 5 days ahead, that forecast can be used by them. And that is already being affected. The weather prediction in the country has now improved to some extent, because in the last 3-4 years, India Met Department has implemented a very high resolution forecast model. So these information are now sent regularly to the farmers through something called Agro-Math Advisory. Information on humidity, temperature and rain is sent through a certain mobile network to a large number of farmers. They utilize that in their decision making. An economic survey has been carried out. This institution has estimated that this might have saved them about 40,000 crores. IITM has a model which actually makes extended range prediction. This information is now being transferred through IMD, passed on to the farmers. We are working closely with IMD and the farming community. With all that, we are working together to make this information available to the farmers.
So now a quick diversion from all the serious talk. What are your hobbies outside of research? What do you like to do on your day off?
I like to read a book. I used to play soccer, but now I have become too old. And I don't get enough time to really... See, I come from a vernacular medium school, and the English was quite poor to start with. And when I went to PRL, actually my English was terrible. And I started reading some books and then built up a little bit of vocabulary. I used to like reading Three Men in a Boat by Jerome K. Jerome. It's a lovely, hilarious. I started from there. And then I read a lot of P.G. Woodhouse books. These days I read a lot of thrillers. Mostly I like to read Dan Brown. I have read some of the Indian authors also, like Amis and Asin Sangvi. Mostly thrillers.
I would ask you to share some words of wisdom for students who are interested in pursuing a career in science.
Science is always exciting. There are so many things that we don't know. So much to learn. The life is always a learning experience, and science is a structured way of learning. But for learning, you have to have a passion. I like to tell the young friends that if you have a passion, you can achieve anything. My personal experience is that I had a passion to do something, learn something, and it doesn't happen overnight. There will be times when you will be frustrated, but if you have the passion, then you will overcome them. What used to happen is that one student will join and start doing some research work, but that very specific narrow area he will expertise. But then at the end of the day, the most interesting research today is the interface of different areas.
Thank you, Professor Goswami. We look forward to chatting with you again sometime on Science Radio. We will be back next week with another episode of Science Radio. We would love to hear from you. Do write to us. Our email ID is radioiserpune, radio IISER Pune @gmail.com. This is your host, Sourajit Basu, signing off.